Hello class, I'm going to show you how we are going to do this prac. Let's start with the different parts of the prac, and then the next step is going to be starting the performing all the steps we need to get the data. First, we have initial valve to adjust the flow rate in this pipe. So we are going to have water flow in this pipe, and the flow rate is going to be adjusted using this pipe. Then we have venturi here in the pipe as a first flow rate measuring apparatus here. Before and at the throat of the venturi, we have two tubes which we can read the pressure of those 2 points, and we are going to connect these two tubes to these digital pressure readers. Then flow comes in. We have another flow rate apparatus, which is orifice meter. As you can see here, orifice meter is basically a plate with a hole at the center, and for the orifice meter we have before orifice and after orifice flow the pressure reading tubes connected, and again we are going to connect these two tubes to the digital pressure readers. So flow is going to come here, and finally we are going to drain it into this channel. Because we need to know what is the flow rate, we are going to calculate flow rate or ball flow rate using this scale. We have a bucket, empty bucket, and this bucket is going to have 20 kilograms of water inside. The empty bucket weight is about 13 kilograms, and you are going to find the empty bucket using this scale. How we can use this scale? We have different stones here, and using these stones, we need to balance over this gauge. Whenever this level was balanced, we can read the weight of the empty bucket. Okay, now I want to find the empty bucket weight. As you can see, bucket is dry, no water is inside, and it's on the scale. Now let's zoom it over the scale itself. As you can see, scale is not balanced, so it's kind of upward. So the weight of the bucket is very high. So I don't know what is the weight. I'm going to find one of the stones. For example, this is 10 kilogram stone. I'm going to put it here. The level didn't move. So it means the weight of this empty bucket is higher than 10. Is it 20? I know that it's not 20, otherwise I put 20 kilogram stone here. So it should be between 0 to 10. So for smaller weights, I'm going to use this one. So 11. So 10 here, 1 here, 11. I don't have this balance, so I move to 12. Nothing. 13. Now you can see it start moving. As you can see, we have a balance here. So 10 kilogram stone plus this weight, which is going to be 12.8 kilogram, is going to be empty bucket weight. Now I want to have about 20 kilogram of water inside this bucket. So I balance the empty bucket weight with these stones. I'm adding a 20 kilogram stone here, like this. So whenever I had 20 kilogram of water, this shaft is going to move, and I'm going to know now I have 20 kilogram water. So if I want to find bulk flow rate, I'm going to push this scale under the flow rate, and whenever it reaches to the 20 kilogram, the scale is going to show me by this shaft is going to start moving, and I'm going to know I reached to the 20 kilogram. How long it takes to fill 20 gram of water is going to be important for me. So I'm going to have a stopwatch here to record the time I needed to have this 20 kilogram of water inside this Okay, now I need to connect these pressure taps to our pressure gauge. I need to turn on the valve behind each phase to have water flow inside, because I don't want to trap any air bubble between the pressure phase taps and pressure gauge. So I'm turning on these two. Now I have flow, and I'm going to easily just push the tape over the inside our pressure gauge. Okay, I connected first two. Now again, same thing is going to happen. Open the cage. The valves are open. Now we have water here, and there I'm connecting them to now all pressure taps are connected to our pressure gauge, and we can read pressure before venturi throat and venturi throat, before and after orifice, using this digital pressure gauge. Now I need to read the pressures. Before reading, it's better to reset the pressure gauge, otherwise we may read wrong number. To reset, I select button, and as you can see it says here reset, and I press enter. So that is going to reset our pressure gauge, digital pressure gauge. Select. Okay, let me turn on. Select, reset. Again for this one, select, reset. Select and reset. Okay, Now you can see the pressure for first one and second one, which is before the venturi throat and at the venturi throat. You can see the pressure. And interestingly, the pressure at the throat is lower than pressure before throat. Why? You need to answer that question. Let's check for the orifice meter. Pressure after orifice, it's negative. Again, why? You need to find out why we have negative pressure there. But before orifice, it is positive. Okay, so let's focus on the geometry of the orifice meter and venturi. As you can see, the design of venturi is very smooth. We can see flow comes closer to the throat, and we have a very nice geometry here, so it's not going to create a turbulent flow here. So the turbulence is going to be minimal. But for orifice, it's like a blocking effect. We have a flow blocked with that plate with the orifice at the center. So we expect to see two different behavior there, and the calibration coefficient of those two, orifice meter and venturi, supposed to be different. Which one supposed to be closer to the one? Which one is much smaller than one? And why? Another thing here, you can see we have one pipe with both orifice meter and venturi mounted or attached to this one pipe. Why we did this? Why we don't have two pipes? One of them investigating venturi meter, as you can see here, the first one, and the second pipe just for orifice meter. Why we can have both of them in one pipe, and we can say that the effect of venturi on the orifice meter is minimum. Why? And finally, which one you select for your project if you want to find a flow rate? Do you prefer orifice meter or venturi? What is the criteria of selecting them? Okay, after you find and read pressure using digital pressure gauge we have, you need to find bulk flow rate. As I told you, you are going to push this scale with the bucket on it under the flow rate. Have your stopwatch ready, so whenever water touches the bucket, we are going to start our time, and then when the weight of the water reaches 20 kilograms because of the stone, this handle is going to start moving, and we are going to stop the stopwatch. The time or takes for the bucket to fill 20 kilograms is going to help us to find bulk flow rate or Q. Let me show you how we do it. So, I'm going to get into this. Still I'm not ready. So, I have my stopwatch here. 1, 2, 3. Now my stopwatch starts working. I'm careful when I'm going to have this handle moving, and whenever it starts moving, I'm going to stop it. So, start moving, stop. Now I have 18 second 0.06, I know that it takes, for this flow rate, it takes 18 seconds to fill 20 kilogram of water in the bucket. And the next step is going to be taking out of the water stream, empty this, and repeat this 3 times. Why 3 times? Because in this whole prac, this section of the prac is going to be most inaccurate one because of the water splash, a lot of inaccuracy regarding the time you are going to find. When you empty the bucket, there are some water left in the bucket. So therefore, we try to increase the accuracy. For each flow rate, we repeat this process 3 times to find how long it takes for this flow rate to fill 20 kilogram of water in this